Hi there and welcome to the channel. Hope you're keeping well. Now in the previous video, about 2 weeks ago I released it actually, we looked at a 3-band end-fed half wave for 40, 20 and 10 meters. I had a loading coil at the top of the 10 meter part of the wire. That's the first 10 meters of the wire. Had a 34 microhenry coil which allowed us to bring in 40 meters and act as a trap for 20 meters and indeed 10 meters as well as a full wave. Now that's the issue, because if you remember from that video, and I'll put a link up there in case you haven't seen it, 40 meters is obviously a compromise. As 20 meters was a full-sized half wave, that went really well. 10 meters was probably the biggest compromise of the lot, because as a full wave, we run into one or two issues. Let me show you here. So as we can see, with a half wave, we've got our conventional sort of 20 meter end-fed half wave, 10 meters of wire, fed at the base of the 49 or 56 to 1. We've got that as a vertical, okay? So we've got that mounted, say, on a 10 meter pole, fiberglass pole. And on 20 meters, the antenna acts as a half wave with the current maximum in the center, as we'd see with a sort of vertical dipole. And if you rotated that horizontally, that would be the pattern as well, coming out from the center. And we get some good performance with that. Now, the issue is, if we go to 10 meters, we see we've got a couple of major lobes coming out there, one about a quarter wave up and one 3/4 waves up, because don't forget, on 10 meters this antenna is now a full wavelength long. Gives us a good match to our 49 or 56 to 1 transformer, whatever we're using, but the problem is with 10 meters we see a reduction in that sort of low elevation angle gain that we see. Now with a conventional sort of half wave end fed, if you like, we should see gain of around -5 to -5.5 dBi off a sort of 5-degree elevation if we sort of mount this antenna very near the ground, for example. Now with this version of the same antenna but used on 10 meters as a full wave, it does give us a good match to our 49 or 56 to 1 transformer, but as we can see here, we see a reduction in the gain that we get, and we'll see why in a minute. We've now got -9 dBi. So we're about 3.5 dBi down with the half wave. Now, we know 10 meters can open, and 10 meters can be a good band to work, a very good band to work DX with most sorts of antennas. So we can still work DX with this antenna, but if we want to optimize it, we are down a bit with our half wave. And going back to the diagram just very quickly, we can also see that the peak elevation angle for this antenna is about 36 degrees compared to 20 degrees. So it's offering us, as we can see here, look, we compare it with the 20 meter half wave. Our 10 meter full wave is in blue. On the right hand side, you can see we have much our stronger lobes are at much higher angles compared with the half wave. But say we want to optimize it and keep 20 meters, so what we can do, what can we do? What we can do is, we can see in a minute, we can put in a loading coil, which will act like the other one did, the 34 microhenry one did on the other antenna. Around 15 microhenries or so will be fine. And what this will then do for the loading coil, will act as a trap for 10 meters and also load up 20 meters as well. Just looking at this diagram quickly, this is how it looks. We're going to have basically 5 meters of wire for the 10 meter half wave, and then we're going to put the loading coil at above that at about 15 microhenries or so, and then we'll have a bit of wire going above it, but that won't be a full length half wave on 10 meters. It won't be anywhere near 10 meters long. What are our options? Well, I've just modeled this quickly on MMA&A, and we've looked at different ratings or different amounts of loading for our loading coils. So we looked at 15 microhenries, we looked at 12 microhenries, 9, and we looked at 7 microhenries as well. So let's have a look then at these different versions. So we can see here, for example, we've got a 15 microhenry version. That's got the most windings on it. That will create the biggest loading, if you like, and that will shorten our 20 meter version the most. Don't forget, we're putting this just around, as it says there, 5.15 meters up from the base. So that'll choke off 10 meters. Now we're only adding just under a meter, about 89 centimeters according to that, of wire above it. So the overall antenna will be, according to this, will be 6.04 meters long. But this is using uninsulated wire. So if you add if you're going to use insulated wire, which most of us will, that'll come down comfortably, I think, to below 6 meters in length. So a useful antenna for portable, maybe SOTA, that kind of thing, to sling up which will give you both bands. Though of course there isn't a free lunch. When you reduce the size of the antenna so much, in this case by 40% on 20 meters, you will see one or two trade-offs. And as you can see here, this would be basically that a 5-degree elevation will be about minus 7.4 dBi on 20 meters. Now that figure in red, that minus 2 dBi, compares it with the normal, if you like, full-size half-wave ground-mounted. Notice though that on 10 meters, because we've changed the antenna, I should say, to being just a normal half-wave trapped at the top, that we've suddenly gone from minus 9 to minus 5.6 dBi. So we've improved it from the full wave by just about 3.5 dBi. At the bottom though, you'll see the 2-to-1 bandwidth. 10 meters isn't a problem, but 20 meters now down to 320 kilohertz. So we're not quite covering the whole band at less than 2-to-1. But still, if you're mainly a phone operator, you should be okay. And if you're certainly into FT8 or FT8 or CW, whatever, then you've obviously got a fairly narrow sort of strip of the band to aim for. You should be absolutely fine. So to be honest with you, it's not a huge deal breaker if you're one of the other type of operator, or favour one of the other type, because you don't have the whole band to try and cover anyway. We can, of course, reduce the loading, so we can go from 15 microhenries, we can reduce the loading to 12 microhenries. As we see here, it does change things a little bit, not by a huge amount. The overall length of the antenna is now 6.4 meters because there's less loading on the 20 meter part of it. 10 meters is slightly longer, so 6.4 meters long. 10 meters doesn't change at all. 20 meters just improves slightly. So not much of a change there really. Even the bandwidth at the bottom doesn't change much. It just about covers the whole band now. We can reduce the loading even more, say to 9 microhenries. Now if we do that, then our total length of the antenna is suddenly 6.92 meters. That'll come down a bit again. Don't forget we're using uninsulated wire here in the modelling. We are now seeing 10 meters just weaken slightly. It's still 3 dBi better than our full wave look. But 20 meters has now improved a little bit. It's now come up to minus 6.7. So it's now within 1.5 dBi of the conventional half wave. And our bandwidth has suddenly increased a fair bit as well for 20 meters. And finally, if we really wanted to go for it, we could reduce our coil to 7 microhenries. So what that will do, that would increase the total length of the antenna to 7.3 meters or so. Again, slightly less for insulated wire. And that's about that's going to end up being probably about 70% the length of the antenna of a conventional halfway for 20 meters. 10 meters and 20 meters are very similar now, aren't they? Look, minus 6.3, minus 6.4. But 10 meters is still nearly 3 dBi better. But 20 meters is only a dBi down on the half wave. So if you're looking for something to balance out and act as a real compromise between the two, then less loading seems to be the best way. But of course, you will have a longer antenna. But if you don't mind that, then you should have a pretty decently performing antenna. And if we just quickly go back to that final piece, at the bottom now for 20 meters, we can see the bandwidth is now 620 kilohertz, which is way more than we need a 2-to-1 or less SWR for the band. So there we go. Food for thought. I'll certainly be trying this antenna out. It looks like a really good option. So instead of having a trap, what we're now using is a loading coil with enough inductance to load up 20 meters and shorten it, and enough capacitance to actually choke off 10 meters. So there we are. By the way, if you want to find out how to make those particular loading coils, I'll put a link in the description below for the website I used. It's one that many hams use actually, and it provides really good guidance. These coils are very easy to make, so maybe I'll do a video on that one day. But for now, I hope that's given you food for thought. And if you want to subscribe to the channel, there'll be a link coming up on your screen. And certainly, if you want to click on another video, there'll be another one coming up very shortly, which may interest you too. Thanks for watching. We'll catch you again on another one. 7-3.